Today we're going to be looking at how you can create your very own image classification using the OpenCLIP Python library and Marqo's e-commerce embedding models. Let's dive straight into it. So for this video, we're going to be using this Google Colab notebook, which I'll put in the description of the video, and I'll also put a link to it in the pinned comments so you can have a go and play around with the code yourself. Now, if you are new to Google Colab, I have this resource, this article that I created here, just going through step by step how you get set up, but it's incredibly easy and super helpful when it comes to building coding projects and machine learning projects. So I'll also put the link to this in the pinned comment and the description. Now, as a quick side note, if you prefer to watch videos and have an article alongside, I know the Google Colab notebook has a lot of explanation, but we also have this blog post that goes through all of the code behind it and some extra explanations as well. So I'll also put this link in the pinned comment and the description. Now let's get stuck straight into it. So firstly, this notebook actually gives you the option to perform image classification with OpenCLIP, which is what we see here, but also with Hugging Face Transformers library as well. The fantastic thing about these embedding models is they can be loaded with both of these really useful libraries, and so we've collated both of the examples here. Don't worry about the Hugging Face Transformers, we do have a separate video, separate article on that, but if you want to play around with it then feel free. So what exactly are the embedding models that we're going to be using today? So they are actually Marqo's newly launched e-commerce embedding models. Now if you click on this link here, it will redirect you to this Hugging Face collection for Marqo e-commerce embeddings. So these are embedding models that Marqo have recently released that are state-of-the-art for e-commerce applications. So the classification we're going to be building today will be specifically image classification for e-commerce, which is, really, really exciting. If you're interested in all of the benchmarks and extra information and resources, this Hugging Face collection has both of the models here, so you can have a look, some evaluation data sets, and some Hugging Face spaces that you can play around with. This Hugging Face space here is actually classification similar to what we'll be doing in today's video. So I encourage you to check it out and read a little bit more about the embedding models if you're interested. So the OpenCLIP section here, the first thing that we need to do is pip install relevant packages. Now that was very quick to install, so we have the relevant packages that we need, the relevant libraries. The first thing that we're going to do is load the model and tokenizer. So what this will do, quite literally as I just said, it will load the model from Hugging Face and it will also load the tokenizer as well. So notice here that for it to work with OpenCLIP, we need this Hugging Face hub kind of prefix here. And so we're using the L model, which you can see in the collection, which is this model here. But if you want, you could have also used the B model. The reason we use the L model is because it's actually the best performing model when we did the benchmarking. So we're going to use the L model, and again note that we need the Hugging Face prefix here. So we're just defining the model name, and then we create variables model, preprocess train, preprocess val, and we are loading the model itself using the OpenCLIP library. And then this section here is loading the tokenizer itself. So if we run that, it will do the downloading of the model itself, so we can start using the embedding model to perform classification. Now for those of you that don't know what an embedding model is, it's a machine learning model that takes text and images in our case, but also other types of data and represents it in a numerical format. And that allows you to do things like similarity search in the vector space, which is fantastic. Now that's really helpful because if you have an image that is represented in some sort of numerical way and a text that's represented in some sort of numerical way, and the text represents the image, then they'll be close in the vector space, and so you kind of retrieve those two. That's what an embedding is, and embedding models create those embeddings. Awesome. So now that we've loaded the model and tokenizer, we're going to tokenize the e-commerce items. So the first thing we want to do is define the e-commerce items that we'll use for classification. Now something that's very important to note here, you must, if you're taking a URL of a specific image, let's say a bicycle helmet in our case, then you need to define that in your e-commerce item. So for example, if we take something that's not mentioned here, like a cheese grater for example, then if you were to upload an image of a cheese grater to this classification that we're building, the e-commerce embedding model wouldn't be able to just know what it is because there isn't a text description that's similar in space. It could give its best shot at it, but because we're only saying these are the items that we want to classify, if there's no cheese grater, it might look for something that's the closest to it, which I think in this case would be a microwave, I think, or a plate, because it's, yeah, kitchen items. But anyway, something to mention is the e-commerce classification that we have, this Hugging Face space, which I encourage you to play around with. This has around 200 different items, and so yeah, I encourage you here to add some extra items, especially if you want to classify them. Obviously make sure they're e-commerce items, because these embedding models are e-commerce. The next thing we want to do is tokenize the text. So we're tokenizing these e-commerce items that we have here, and then we're just saying, well, print that we're going to encode these text features, and that's what this section does here. So I'm just checking I've run that. Yep, we're going to run this one, and shouldn't take too long to encode the text features here using the model here. So we're using the model to encode the text features, and this is normalizing them here. Now the next step is to fetch and process the image that we want to use for the classification. So the idea is we're going to upload an image and then we're going to classify it. And for this example, we are using this image here, which is a bicycle helmet, and it's an image URL. And I will be showing you, after we've run through all of this code, how you can change this and update it to classify your own URLs. But for the sake of this, we basically take the URL and then this bit of code here, which will try and get the image URL, and if it returns status 200, then we know that it's been retrieved successfully. And so we define the image by this line here, and we pre-process it, and then we just plot the image. And the reason for that is I wanted to show you exactly what image we're going to be classifying. So we display the image in Google Colab, and we raise an error if you're unable to retrieve an image URL. So I'm sure if we just put JP there instead of JPG, then it would return unable to retrieve the URL. So if we run this, it should take the URL and plot the bicycle helmet, which indeed it is right here. Perfect. The next thing we want to do is encode the image features. This is exactly what we did with the text features. We're encoding the image into a numerical representation, and basically this allows the model to compare this image with the list of e-commerce items and display which are the top 5 predictions. So this section here is encoding the image. As we can see, we're taking the model and it's encoding the image that we defined above, which was the pre-processed image. It's normalizing it, and then it's saying, let's calculate the probabilities for each of the e-commerce items that we already have, so the text features and the image features. So if we run this, this is just going to obtain the top 5 confidences, so top 5 predictions for this. And when we display the top 5 predictions, as we can see, we expect the bicycle helmet to come out on top, and it does indeed. We have 1. Now this should actually be multiplied by 100 here, so yeah, this should be 100% prediction. We can now decide to obtain a different image URL, so let's have a look at how we can do that. So where do we define the URL? We defined it in here. Let's do perfume. Already searched for this because I use this in the transformer video, but I selected this image. Let's have a look, and I'm going to open this image in a new tab, and there we go. So I can copy the URL of this image, we can input it into here, which is where our image was, paste it. Now we can run this again, and indeed it displays the perfume. We can run this and this again, and once it has done all the encoding of the image and displays the top 5 predictions, we should expect to see perfume. Yep, we do. Perfume as the top. Fantastic. So that's how you can input your own image URL into here and get it to display the top 5 predictions. Not only do we have videos on classification with transformers and OpenCLIP, there is also a video on how you can create your very own e-commerce search application. So make sure to check out that video if you're interested. Thank you so much for watching, and we'll see you all in the next one.